Picture this, a vast, swirling sea of cosmic dust and gas, painted in hues of deep purples, vibrant blues, and fiery reds. This is a nebula, one of the most breathtaking sights in the universe. Now, what if I told you that this stunning cosmic masterpiece isn't just something we observe from afar? What if we're living inside one right now? That's the bold claim some astronomers are making, and it's a theory that's as fascinating as it is controversial. Could our solar system, our planet, and even our lives be unfolding within the boundaries of a nebula? It's a mind-bending idea that challenges everything we thought we knew about our place in the cosmos. Today, we're diving into this extraordinary hypothesis, exploring the evidence, the science, and the implications of what it would mean to call a nebula home. So, buckle up and get ready to explore a universe that might be closer and more mysterious than you ever imagined. Let's uncover the secrets of the cosmos together. Now, let's take a closer look at what a nebula actually is. Imagine a colossal cloud in space, not made of water vapor like the clouds we see on Earth, but instead composed of dust, hydrogen, helium, and other ionized gases. These cosmic clouds are scattered across the universe, often stretching for light years, and they come in a stunning variety of shapes, sizes, and colors. Some glow with vibrant hues, while others appear as dark silhouettes against the backdrop of stars. Nebulae are often categorized into different types based on how they interact with light. Emission nebulae, for example, are like cosmic light shows. They glow brightly because the gases within them are energized by nearby stars, emitting their own light in dazzling colors. Reflection nebulae, on the other hand, don't produce their own light. Instead, they reflect the light from nearby stars, giving them a softer, more ethereal appearance. Then there are dark nebulae, which are dense enough to block out the light from stars behind them, creating shadowy patches in the night sky. But nebulae aren't just beautiful to look at, they play a crucial role in the life cycle of stars. These vast clouds are essentially stellar nurseries, the birthplaces of stars. Within their swirling depths, gravity pulls gas and dust together, forming dense clumps that eventually ignite into new stars. Over millions of years, these stars grow, evolve, and sometimes even explode, scattering their material back into the nebula to begin the cycle anew. So when we talk about nebulae, we're not just talking about cosmic art, we're talking about the very fabric of the universe, the building blocks of stars, planets, and even life itself. And if astronomers are right, this incredible process might not be happening light years away. It could be happening right here, all around us. Now, let's shift our gaze closer to home and explore a fascinating idea that has captured the imagination of astronomers and stargazers alike: the Nebula Hypothesis. What if, instead of being distant cosmic wonders, nebulae are much closer than we think? What if our solar system, and even Earth itself, are embedded within one of these vast, glowing clouds? This is the bold claim that some scientists are beginning to consider, and it's a theory that could reshape how we see our place in the universe. The idea that we might be living inside a nebula isn't entirely new. In fact, it has roots that stretch back centuries. Early astronomers, peering through rudimentary telescopes, noticed faint, hazy patches in the night sky. At first, they thought these were distant star clusters or even other galaxies. But as our understanding of the cosmos grew, so did the realization that these patches were something else entirely: nebulae, vast clouds of gas and dust. Over time, as technology advanced, astronomers began to wonder, could some of these nebulae be closer than we thought? Could one of them be right here, surrounding us? Fast forward to modern times, and this hypothesis has gained new traction thanks to groundbreaking observations. Scientists have detected traces of interstellar gas and dust within our solar system, materials that bear a striking resemblance to those found in known nebulae. For example, the Local Interstellar Cloud, a region of space through which our solar system is currently moving, contains particles and gases that align with the composition of certain nebulae. This has led some researchers to speculate that we might be passing through or even embedded within a nebula right now, but how could this be possible? After all, nebulae are often associated with star-forming regions, places where new stars are born. If we're inside one, wouldn't we see more dramatic signs like intense radiation or the birth of new stars nearby? The answer lies in the diversity of nebulae. Not all of them are hotbeds of stellar activity. Some are quieter, more diffuse, and less energetic. These quieter nebulae could exist around us without the dramatic effects we might expect, making their presence harder to detect. Recent advancements in technology have also played a key role in reigniting this debate. Telescopes like Hubble and the James Webb Space Telescope have provided unprecedented views of nebulae, revealing their intricate structures and compositions in stunning detail. These observations have allowed scientists to compare the materials in our solar system with those in distant nebulae, finding intriguing similarities that keep the hypothesis alive. So, while the idea of living inside a nebula might sound like science fiction, it's a theory grounded in real astronomical observations and historical curiosity. It challenges us to rethink our understanding of the cosmos and our place within it. Could we truly be floating in a cosmic cloud, surrounded by the very materials that give birth to stars? The answer remains elusive, but the journey to uncover it is as thrilling as the question itself. Now, let's take a closer look at the evidence that has sparked this intriguing hypothesis. One of the key pieces of support comes from the detection of specific gases and dust particles within our solar system. These materials, often referred to as interstellar matter, have been found to closely resemble the composition of known nebulae. For instance, scientists have identified traces of hydrogen, helium, and even heavier elements like carbon and oxygen floating in the space between planets. These elements are not just random debris, they match the chemical fingerprints of the gases and dust found in distant nebulae. But how do astronomers analyze these clues? It all starts with advanced instruments and techniques. Space probes like Voyager 1 and 2, which have ventured beyond the edges of our solar system, have collected data on the density and composition of interstellar particles. These measurements reveal that the material surrounding us is not just empty space, it's filled with fine dust and gas that aligns with what we see in nebulae. Additionally, telescopes equipped with spectrometers break down the light from these particles, allowing scientists to identify their chemical makeup. This process, known as spectroscopy, is like reading a cosmic barcode, revealing the unique signatures of the elements present. Another fascinating piece of evidence comes from the way light behaves as it travels through our solar system. Astronomers have observed subtle changes in the color and intensity of starlight as it passes through the interstellar medium. These changes, called interstellar reddening and extinction, occur when light interacts with dust particles, scattering certain wavelengths and dimming the overall brightness. The patterns of these changes closely match what we see in nebulae, suggesting that similar processes are at work right here in our cosmic neighborhood. Of course, not all evidence is direct. Some clues come from simulations and models that recreate the conditions of interstellar space. By inputting data from observations, scientists can predict how gases and dust would behave if our solar system were embedded in a nebula. These models show that the presence of such material could explain many of the phenomena we observe, from the distribution of cosmic rays to the way solar wind interacts with the surrounding environment. While the evidence is compelling, it's important to note that it's not yet conclusive. The similarities between the materials in our solar system and those in nebulae are striking, but they don't definitively prove that we're living inside one. However, they do provide a strong foundation for further exploration and debate. As technology continues to advance, astronomers are hopeful that new discoveries will shed more light on this cosmic mystery. bringing us closer to understanding whether we truly reside within a nebula. Now turning to the Local Interstellar Cloud, let's explore this fascinating region of space that our solar system is currently passing through. This cloud, often referred to as the local fluff, is a relatively small and diffuse area filled with gas and dust. It spans about 30 light-years across and is part of a larger network of interstellar clouds within our galactic neighborhood. What makes this cloud particularly interesting is its composition, primarily hydrogen and helium, with traces of heavier elements like carbon and oxygen. These elements are strikingly similar to those found in nebulae, which raises the question, could this cloud be a remnant of a larger nebula? The Local Interstellar Cloud isn't just a random patch of space. It's part of a dynamic environment shaped by the forces of supernova and stellar winds. Scientists believe that this cloud was formed by the explosion of massive stars millions of years ago, scattering their material across the region. As our solar system moves through this cloud, it interacts with the gas and dust, creating a unique environment that astronomers are eager to study. For instance, the Sun's heliosphere, the protective bubble created by solar wind, acts as a shield, deflecting much of the interstellar material. However, some particles manage to penetrate this barrier, providing valuable clues about the cloud's composition and structure. One of the most intriguing aspects of the Local Interstellar Cloud is its potential connection to the Nebula Hypothesis. If our solar system is embedded within a nebula, this cloud could be a localized concentration of that larger structure. The similarities in composition between the cloud and known nebulae are hard to ignore. Both contain the same basic elements, and both play a role in the life cycle of stars and planetary systems. This raises the possibility that the Local Interstellar Cloud is not just a passing feature but a piece of a much grander cosmic puzzle. As we continue to study this cloud, new questions emerge. How long will our solar system remain within it? What other secrets does it hold about the origins of our cosmic neighborhood? While we don't yet have all the answers, the Local Interstellar Cloud offers a tantalizing glimpse into the possibility that we are, in fact, living within a nebula. And as our understanding of this region grows, so too does the potential to uncover even more about the mysteries of our place in the universe. Now shifting our gaze closer to home, let's explore the cosmic dust and gas that permeate our solar system. These tiny particles and wispy gases might seem insignificant, but they hold profound clues about our cosmic origins. Scattered throughout the space between planets, this material is thought to be a remnant of the ancient nebula from which our solar system formed billions of years ago. Cosmic dust, often no larger than a grain of sand, is made up of elements like silicon, carbon, and iron. These particles are remnants of the same building blocks that once coalesced to form planets, moons, and even life itself. Gas, on the other hand, primarily consists of hydrogen and helium, the same elements that dominate the composition of nebulae. Together, these materials create a faint but detectable haze that fills the vast expanse of our solar system. One of the most fascinating aspects of this cosmic dust and gas is how it interacts with sunlight. When sunlight hits these particles, it scatters, creating a phenomenon known as zodiacal light. This faint glow can sometimes be seen just after sunset or before sunrise, appearing as a soft, triangular band of light stretching upward from the horizon. It's a subtle reminder that even the seemingly empty spaces of our solar system are teeming with remnants of its birth. But cosmic dust and gas aren't just relics of the past, they also play a role in shaping the present and future of space exploration. For instance, spacecraft traveling through the solar system must account for the presence of these particles. While most are too small to cause damage, larger grains can pose a risk to sensitive instruments and equipment. At the same time, studying these materials helps scientists better understand the conditions that existed during the formation of our solar system. The distribution of cosmic dust and gas isn't uniform. Some regions, like the asteroid belt, contain higher concentrations, while others, such as the outer reaches of the solar system, are relatively sparse. This uneven distribution provides valuable insights into how our solar system evolved over time. For example, the presence of heavier elements in certain areas suggests that these regions were once part of denser, more active zones within the original nebula. As we continue to explore our solar system, the study of cosmic dust and gas remains a key area of research. Missions like NASA Stardust and the European Space Agency's Rosetta have collected samples of these materials, offering a glimpse into the early days of our cosmic neighborhood. Each discovery brings us closer to answering the question, are we living within the remnants of a nebula? The presence of these materials not only connects us to the past but also hints at the broader mysteries of the universe. As we uncover more about cosmic dust and gas, we gain a deeper appreciation for the intricate processes that shaped our solar system and perhaps our place within a nebula. Now turning to the heart of cosmic creation, let's explore how stars are born within the swirling depths of nebulae and how this process might mirror the origins of our own solar system. Nebulae, often called the cradles of stars, are vast clouds of gas and dust where gravity works its magic, pulling material together until it ignites into the fiery birth of a star. This process begins when a region within a nebula becomes dense enough to collapse under its own gravity, forming a protostar. Over millions of years, this protostar gathers more material, growing hotter and denser until nuclear fusion begins and a new star is born. Our solar system likely began its journey in a similar way. Billions of years ago, a portion of a massive nebula collapsed, forming the Sun at its center. The remaining material, swirling around the young star, began to clump together, eventually forming planets, moons, and other celestial bodies. This process, known as accretion, is a hallmark of star systems born within nebulae. The similarities between our solar system and others observed today are striking. For instance, many exoplanetary systems discovered in recent years show patterns of planet formation that closely resemble our own, with rocky inner planets and gas giants farther out. One of the most fascinating aspects of star formation is the role of cosmic dust and gas. These materials not only provide the raw ingredients for stars, but also influence the structure and composition of the resulting planetary systems. In our solar system, the presence of heavier elements like silicon and iron in the inner planets suggests that these regions were once part of a denser, more active zone within the original nebula. Meanwhile, the outer planets, rich in hydrogen and helium, reflect the lighter elements that dominated the nebula's outer edges. The process of star formation also sheds light on the diversity of celestial bodies we see today. Some stars form in isolation, while others are born in clusters, surrounded by siblings that share the same cosmic nursery. Our Sun, for example, may have once been part of a star cluster that has since dispersed over time. This idea is supported by the discovery of stars with similar chemical compositions and ages, hinting at a shared origin. As we study star formation within nebulae, we gain a deeper understanding of our own cosmic beginnings. The swirling clouds of gas and dust that gave birth to our solar system are not unique. They are part of a universal process that has shaped countless star systems across the galaxy. By comparing our solar system to others, we can piece together the story of how planets, moons, and even life itself came to be. This connection between nebulae and star formation is more than just a scientific curiosity. It's a reminder of our place in the universe. Every star, every planet, and every speck of cosmic dust is part of a grand cosmic dance that began billions of years ago. And as we continue to explore the mysteries of nebulae and star formation, we uncover not only the secrets of our past but also the possibilities of our future. Now shifting our gaze to the protective shield that surrounds our solar system, let's explore the heliosphere and its crucial role in shaping our cosmic environment. The heliosphere is a vast, bubble-like region of space dominated by the Sun's influence, created by the constant flow of charged particles known as the solar wind. This wind streams outward from the Sun at incredible speeds, pushing against the interstellar medium, the sparse mix of gas and dust that fills the space between stars. The boundary where the solar wind meets this interstellar material is called the heliopause, marking the edge of the Sun's influence. The heliosphere acts as a protective barrier, shielding our solar system from much of the high-energy cosmic radiation that permeates interstellar space. Without it, these harmful particles could strip away our atmosphere and make life on Earth far more challenging. But the heliosphere isn't just a shield, it's also a dynamic interface where the Sun's energy interacts with the material beyond our solar system. This interaction creates a fascinating interplay of forces, shaping the environment around us and offering clues about the nature of the space we inhabit. One of the most intriguing questions is whether the heliosphere's interaction with the interstellar medium could hint at the presence of a surrounding nebula. As our solar system moves through the galaxy, it passes through different regions of space, each with its own density and composition of interstellar material. Some scientists suggest that the specific patterns of gas and dust detected at the heliopause might resemble those found in known nebulae. For instance, the presence of certain elements or the way light scatters at the boundary could indicate that we're moving through a region rich in nebula material. The Voyager spacecraft, which have crossed the heliopause and entered interstellar space, have provided valuable data about these interactions. Their measurements show that the density and pressure of the interstellar medium vary, suggesting that our solar system might be passing through a denser region, possibly part of a larger nebula. While this idea is still speculative, it opens up exciting possibilities. If we are indeed within a nebula, it would mean that the same cosmic processes that birth stars and planets are still shaping our environment today. Understanding the heliosphere and its interactions with the interstellar medium not only helps us piece together the story of our solar system, but also deepens our connection to the broader universe. It reminds us that we're not isolated. Our Sun's influence extends far beyond the planets, weaving us into the fabric of the cosmos. As we continue to study these interactions, we may uncover even more evidence that links our solar system to the swirling clouds of gas and dust that have shaped the universe for billions of years. Now, let's venture into the vast expanse of the interstellar medium, the mysterious and often overlooked material that fills the space between stars. This medium is far from empty. It's a sparse but fascinating mix of gas, dust, and cosmic radiation, all swirling together in the void. While it might seem insignificant at first glance, the interstellar medium plays a crucial role in the life cycle of stars and galaxies, and it could hold the key to understanding whether we're living within a nebula. The interstellar medium is composed of several components, each with its own unique properties. About 99% of it is gas, primarily hydrogen and helium, the same elements that fuel stars. The remaining 1% is made up of tiny dust particles, often no larger than a grain of sand. These particles might seem insignificant, but they're essential. They scatter light, absorb radiation, and even serve as the building blocks for new stars and planets. When these materials come together in dense enough regions, they form the breathtaking structures we know as nebulae. So, how does the interstellar medium connect to the idea that we might be living in a nebula? One clue lies in the way light behaves as it travels through space. When starlight passes through the interstellar medium, it interacts with the gas and dust, creating patterns that astronomers can study. These patterns, such as the way light scatters or the specific wavelengths absorbed, can reveal the composition and density of the material around us. If these patterns match those observed in known nebulae, it could suggest that our solar system is embedded within one. Another piece of the puzzle comes from the movement of our solar system through the galaxy. As we travel, we pass through different regions of the interstellar medium, each with its own unique characteristics. Some areas are denser, with higher concentrations of gas and dust, while others are more diffused. If we find ourselves in a particularly dense region, it could indicate that we're moving through a nebula. The Voyager spacecraft, which have ventured beyond the Heliosphere, have already detected variations in the density of the interstellar medium, hinting that we might be in a more concentrated area. Studying the interstellar medium also helps us understand the processes that shape nebulae. For example, when massive stars explode as supernova, they release enormous amounts of energy and material into the surrounding space. This material mixes with the interstellar medium, creating shock waves that compress gas and dust, triggering the formation of new stars and planets. If our solar system formed in such an environment, it would mean that the same forces that created us are still at work in the cosmos today. By examining the interstellar medium, we're not just learning about the space around us, we're uncovering the story of our own origins. Every particle of gas, every speck of dust carries a piece of that story waiting to be decoded. As we continue to explore this cosmic tapestry, we may find even more evidence that links our solar system to the swirling clouds of gas and dust that have shaped the universe for billions of years. And who knows, the next discovery might just confirm that we've been living in a nebula all along. Now, let's take a step back in time to explore how humanity's understanding of nebulae has evolved over centuries. The story of nebulae is as much about human curiosity and ingenuity as it is about the cosmos itself. Long before telescopes, ancient civilizations looked up at the night sky and saw more than just stars. They saw mysterious, hazy patches of light. These early observers didn't have the tools to explain what they were seeing, but their observations laid the groundwork for the discoveries to come. In ancient Greece, philosophers like Aristotle speculated about the nature of these faint, cloud-like formations. They believed they were atmospheric phenomena, part of the Earth's own realm rather than objects in the distant heavens. This idea persisted for centuries, shaping early astronomical thought. It wasn't until the invention of the telescope in the early 17th century that our understanding began to shift dramatically. Galileo Galilei, one of the first to use a telescope for astronomical purposes, observed the Milky Way and realized it was composed of countless stars. While he didn't specifically study nebulae, his work opened the door for others to explore these enigmatic structures. The 18th century marked a turning point in the study of nebulae. Astronomers like Charles Messier began cataloging these faint objects, not because they were interested in nebulae themselves, but because they wanted to avoid confusing them with comets, which were their primary focus. Messier's catalog, which included objects like the Orion Nebula, became a cornerstone for future astronomers. Around the same time, William Herschel, armed with more powerful telescopes, began to study nebulae in greater detail. He proposed that these clouds of gas and dust were the birthplaces of stars, a revolutionary idea that hinted at the dynamic nature of the universe. The 19th century brought even more clarity. With advancements in spectroscopy, astronomers like William Huggins were able to analyze the light emitted by nebulae. This breakthrough revealed that some nebulae were made of glowing gas, while others were dense collections of stars. These discoveries helped distinguish between different types of nebulae, such as emission nebulae and planetary nebulae, and deepened our understanding of their composition and role in the cosmos. The 20th century saw the rise of modern astrophysics, which transformed our view of nebulae once again. Edwin Hubble's work with the Mount Wilson Observatory revealed that some nebulae were actually entire galaxies far beyond our own Milky Way. This realization expanded the scale of the universe and redefined what nebulae could be. Meanwhile, the development of radio astronomy allowed scientists to peer through cosmic dust and study the hidden structures within nebulae, uncovering their role in star formation and the life cycle of galaxies. Today, thanks to telescopes like Hubble and James Webb, we can observe nebulae in unprecedented detail. These instruments have captured stunning images of nebulae, revealing their intricate shapes, vibrant colors, and the processes that shape them. From the ancient Greeks gazing at the night sky to modern astronomers using cutting-edge technology, our journey to understand nebulae has been one of constant discovery and wonder. Each generation of astronomers has built on the work of those before them, bringing us closer to unraveling the mysteries of these cosmic clouds and perhaps even confirming whether we're living within one. Now, as we shift our gaze to the tools that have brought us closer to understanding the cosmos, let's explore how modern telescopes have transformed our view of nebulae. The Hubble Space Telescope, launched in 1990, has been a game-changer in astronomy. Its ability to capture incredibly detailed images of nebulae has allowed scientists to study their structures, colors, and the processes occurring within them like never before. For instance, Hubble's iconic image of the Eagle Nebula, often called the Pillars of Creation, revealed towering columns of gas and dust where new stars are born. This breathtaking snapshot not only captivated the public but also provided astronomers with critical insights into how stars form within these cosmic clouds. Building on Hubble's legacy, the James Webb Space Telescope, launched in 2021, has taken nebula research to an entirely new level. Equipped with advanced infrared technology, Webb can peer through the dense dust that often obscures the inner workings of nebulae. One of its early discoveries includes detailed observations of the Carina Nebula, where it uncovered previously hidden regions of star formation. These findings have deepened our understanding of how nebulae function as stellar nurseries, nurturing the birth of stars and planetary systems. Together, these telescopes have provided compelling evidence that supports the Nebula Hypothesis. For example, Hubble and Webb have detected traces of interstellar gas and dust within our solar system that closely resemble the materials found in known nebulae. These observations suggest that our solar system may indeed be embedded within a nebula, or at least passing through one. Additionally, the telescopes have revealed patterns of cosmic radiation and light that align with what we'd expect to see if we were surrounded by a nebula's diffuse material. The data gathered by these instruments has also helped scientists refine their models of how nebulae interact with their surroundings. For instance, Hubble's observations of the Orion Nebula have shown how stellar winds and radiation from young stars shape the surrounding gas and dust, creating intricate structures and triggering further star formation. Similarly, Webb's ability to detect faint infrared signals has allowed researchers to map the distribution of interstellar material with unprecedented precision, offering clues about how nebulae influence the evolution of star systems like our own. As we continue to harness the power of these telescopes, the Nebula Hypothesis gains more traction. Each discovery brings us closer to understanding whether we are, in fact, living within a nebula, a possibility that would redefine our place in the universe. With every new image and dataset, we uncover more pieces of this cosmic puzzle, inching ever closer to answering one of astronomy's most intriguing questions. Now, as we step into the realm of simulations and models, let's explore how scientists are using cutting-edge technology to test the idea that we might be living within a nebula. Computer simulations have become an essential tool in modern astronomy, allowing researchers to recreate the complex processes of nebulae in a virtual environment. By inputting data gathered from telescopes like Hubble and Webb, scientists can simulate how gas, dust, and radiation interact within these cosmic clouds. These models help us visualize scenarios that would be impossible to observe directly, such as the formation of stars or the movement of interstellar material over millions of years. One of the key challenges in creating these simulations is the sheer scale and complexity of nebulae. These structures are not static. They are dynamic, ever-changing environments filled with swirling gases, intense radiation, and the gravitational pull of forming stars. To accurately model these conditions, scientists must account for countless variables, from the temperature and density of the gas to the effects of magnetic fields and stellar winds. Even with the most powerful supercomputers, these simulations require significant time and resources, and they often rely on simplifying assumptions to make the calculations manageable. Despite these challenges, simulations have provided valuable insights into how nebulae function and how they might influence their surroundings. For example, models have shown how shock waves from supernova can compress gas and dust, triggering the birth of new stars. They've also revealed how the solar wind from young stars can carve out cavities within a nebula, shaping its structure over time. These findings align with observations from telescopes, offering a deeper understanding of the processes at work in these stellar nurseries. Another limitation of simulations is their reliance on observational data. While telescopes provide a wealth of information, there are still gaps in our knowledge, particularly when it comes to the finer details of interstellar material. For instance, the exact composition and distribution of cosmic dust within our solar system remain uncertain, making it difficult to create fully accurate models. Additionally, simulations can only approximate the behavior of nebulae, as they cannot account for every possible interaction or variable in such a chaotic environment. Yet, even with these limitations, simulations have played a crucial role in advancing the nebula hypothesis. By comparing the results of these models with real-world observations, scientists have identified patterns and phenomena that suggest our solar system could indeed be embedded within a nebula. For example, simulations have shown how the presence of interstellar gas and dust could explain certain anomalies in cosmic radiation levels or the distribution of light within our solar system. These findings provide a compelling case for further exploration and research. As we continue to refine these models, they offer a glimpse into the intricate dance of forces that shape our cosmic environment. They remind us that while we may not yet have definitive proof of living within a nebula, the tools at our disposal are bringing us closer to uncovering the truth. With each new simulation, we gain a clearer picture of the universe's grand design and perhaps our place within it. Now, shifting our focus to the invisible forces at play, let's delve into the role of cosmic radiation within nebulae and its potential impact on life here on Earth. Cosmic radiation, a stream of high-energy particles originating from sources like supernova and distant stars, is a constant presence in space. Within the dense clouds of a nebula, this radiation interacts with gas and dust, creating a dynamic and often intense environment. But what does this mean for us if we're truly living within such a cosmic structure? First, it's important to understand that cosmic radiation is not just a distant phenomenon. Even now, Earth is bombarded by these particles, though our planet's magnetic field and atmosphere provide significant protection. However, if our solar system were embedded within a nebula, the levels of cosmic radiation reaching us could be higher. Nebulae, with their swirling gases and magnetic fields, can act as both shields and amplifiers of radiation, depending on their composition and density. This raises intriguing questions about how life on Earth might be affected. Higher levels of cosmic radiation could pose challenges for both biological organisms and technological systems. For humans, prolonged exposure to increased radiation could have health implications, potentially affecting DNA and increasing the risk of certain conditions. On the other hand, life on Earth has evolved over billions of years in an environment with some level of cosmic radiation, suggesting a degree of resilience. The question then becomes, could we adapt to even higher levels if necessary? Technologically, increased radiation could impact satellites, spacecraft, and even ground-based systems. Cosmic rays have been known to interfere with electronics, causing glitches or malfunctions. If we were living within a nebula, these effects could become more pronounced, requiring advancements in shielding and radiation-resistant technology to safeguard our infrastructure. Interestingly, some scientists speculate that the presence of a nebula might also offer protective benefits. The dense clouds of gas and dust could absorb or deflect some of the more harmful radiation, creating a sort of cosmic buffer. This duality, both a source of risk and a potential shield, highlights the complexity of living within such a dynamic environment. As we consider these possibilities, it's clear that the relationship between cosmic radiation and nebulae is multifaceted. While the idea of living within a nebula sparks the imagination, it also invites us to think critically about the challenges and opportunities it presents. Could humanity thrive in such an environment, or would we need to develop new ways to coexist with the forces of the cosmos? These are questions that not only deepen our understanding of nebulae, but also remind us of the delicate balance that sustains life on Earth. With this in mind, let's turn our attention to the broader implications of living in a nebula, exploring what such an environment might mean for our daily lives and our place in the universe. Now, let's step into the realm of imagination and explore what life might look like if we were truly living within a nebula. Picture this, a world where the skies are not just a canvas of stars, but a swirling tapestry of vibrant colors, glowing gases, and shimmering dust clouds. The beauty of such an environment would be nothing short of breathtaking, with every sunrise and sunset painted in hues of red, blue, and gold, illuminated by the light of nearby stars filtering through the nebula's dense clouds. It's a scene that would redefine our understanding of natural beauty, offering a daily spectacle that feels almost otherworldly, but with such beauty comes a unique set of challenges. One of the most immediate would be visibility. The dense clouds of gas and dust that make nebulae so visually stunning could also obscure our view of the broader universe. Imagine looking up at the night sky and seeing not the familiar constellations but a hazy, glowing veil. This could make astronomical observations more difficult, potentially limiting our ability to study distant stars, galaxies, and cosmic phenomena. For astronomers and space enthusiasts, this could be both a frustration and a call to innovate, pushing us to develop new technologies to peer through the cosmic fog. Another challenge would be the impact on our daily lives. The same gases and dust that create the nebula's mesmerizing glow could also affect our atmosphere and climate. For instance, the presence of additional particles in the air might alter weather patterns or even influence the quality of sunlight reaching Earth. This could have cascading effects on agriculture, ecosystems, and even human health, requiring us to adapt in ways we've never had to before. Yet, living in a nebula wouldn't be without its perks. The constant interplay of light and color in the sky could inspire art, culture, and even new ways of thinking about our place in the universe. Imagine the stories, myths, and philosophies that might emerge from a civilization shaped by such a unique environment. The nebula could become a source of endless wonder, reminding us daily of the vastness and mystery of the cosmos. Of course, there's also the question of how such an environment might shape our technology and exploration. The presence of a nebula could offer new opportunities for resource gathering, as the gases and dust might contain valuable elements or compounds. At the same time, navigating through such a dense and dynamic region of space would require advanced spacecraft and instruments, driving innovation in ways we can only begin to imagine. As we ponder these possibilities, it's clear that life in a nebula would be a mix of challenges and marvels. It would push us to adapt, innovate, and rethink our relationship with the universe. And while the idea of living in such an environment may seem far-fetched, it invites us to dream bigger and consider the incredible diversity of cosmic habitats that might exist beyond our own. With this in mind, let's turn our attention to how nebulae compare to other cosmic structures, exploring what makes them truly unique in the grand tapestry of the universe. Now shifting our gaze to the broader cosmos, let's explore how nebulae stand apart from other cosmic structures like galaxies and star clusters. While all three are fundamental components of the universe, each plays a distinct role in the cosmic story, shaped by its size, composition, and purpose. Galaxies, for instance, are vast collections of stars, planets, gas, dust, and dark matter, bound together by gravity. They are the cities of the universe, home to billions or even trillions of stars, each with its own potential for hosting life. Our Milky Way is just one of countless galaxies, each with its own unique shape and structure, from spirals to ellipticals to irregular forms. In contrast, nebulae are like the neighborhoods within these cities, smaller, more localized regions where stars are born, live out their lives, and sometimes die in spectacular fashion. While galaxies span tens of thousands of light-years, nebulae are often just a few hundred light-years across, making them tiny in comparison but no less significant. Star clusters, on the other hand, are like tight-knit communities within these galactic cities. They come in two main types: open clusters, which are loose groups of young stars, and globular clusters, which are dense, spherical collections of older stars. These clusters are often found within or near nebulae, as they are born from the same clouds of gas and dust. However, while star clusters are primarily made up of stars, nebulae are dominated by gas and dust, serving as the raw material for star formation. This makes nebulae the cosmic nurseries where the next generation of stars and planets take shape. What truly sets nebulae apart is their dynamic and ever-changing nature. Unlike galaxies and star clusters, which evolve over billions of years, nebulae can transform dramatically in just a few million years. They are the stages for some of the universe's most dramatic events, from the birth of stars to the explosive deaths of massive stars in supernova. These events not only shape the nebula itself, but also enrich the surrounding space with new elements, seeding the cosmos with the building blocks for future stars, planets, and even life. Another unique feature of nebulae is their incredible diversity. From the glowing emission nebulae, lit up by the radiation of nearby stars, to the dark, shadowy clouds that block out starlight, each type of nebula tells a different story about the processes at work in the universe. Reflection nebulae, for example, scatter the light of nearby stars, creating stunning blue hues, while planetary nebulae, formed from the outer layers of dying stars, showcase intricate, glowing patterns that resemble cosmic art. In the grand tapestry of the universe, nebulae are the threads that weave together the stories of stars, galaxies, and even life itself. They remind us that the cosmos is not just a collection of static objects, but a dynamic, ever-evolving system, full of beauty and mystery. As we continue to explore the universe, nebulae stand as a testament to the creativity and complexity of nature, inviting us to look deeper and wonder what other secrets they might hold. With this understanding of how nebulae compare to other cosmic structures, let's delve into the cultural and philosophical implications of living within such a breathtaking environment, and how it might reshape our understanding of our place in the universe. Now turning to the cultural and philosophical implications of living within a nebula, let's consider how this idea might reshape our understanding of our place in the cosmos. Imagine for a moment that we are not just inhabitants of a small planet orbiting an ordinary star, but part of a vast, glowing cloud of gas and dust that stretches across the heavens. This perspective invites us to see ourselves not as isolated beings, but as integral components of a much larger, interconnected system. It's a humbling thought, one that challenges the notion of human exceptionalism and reminds us of our deep ties to the universe itself. Living in a nebula could also inspire a profound sense of wonder. Picture stepping outside on a clear night and seeing not just stars, but swirling clouds of light and color, illuminated by the energy of newborn stars and the remnants of ancient ones. Such a view would transform our relationship with the night sky, turning it into a canvas of cosmic artistry. It might even influence our art, literature, and spirituality as we draw inspiration from the beauty and mystery of our nebula home. The idea of living within a nebula could become a metaphor for creativity and transformation, reminding us that even in the vastness of space, there is room for growth, change, and renewal. At the same time, this concept invites us to reflect on our place in the universe with a sense of humility. If we are indeed living within a nebula, we are part of a process that has been unfolding for billions of years, a process that has given rise to stars, planets, and life itself. This realization could foster a deeper appreciation for the fragility and preciousness of life, as well as a greater sense of responsibility to protect our planet and the delicate balance that sustains us. It might also encourage us to think beyond our immediate concerns and consider the long-term future of humanity as we navigate the challenges and opportunities of living in such a dynamic environment. The idea of living in a nebula also raises questions about our connection to the universe. If we are surrounded by the same materials that form stars and planets, does that mean we are made of stardust in a more literal sense? This idea has long been a poetic truth, but living within a nebula could make it feel more tangible and immediate. It could inspire a sense of kinship with the cosmos, as we recognize that the elements that make up our bodies were forged in the hearts of stars and scattered across space by the very processes we now observe in our nebula home. Finally, this perspective challenges us to rethink our understanding of time and scale. Nebulae are places of constant change where stars are born and die in spans of time that dwarf human history. Living within such an environment might encourage us to adopt a more cosmic perspective, one that transcends the fleeting concerns of daily life and embraces the grand sweep of cosmic evolution. It's a reminder that we are part of a story much larger than ourselves, one that began long before we existed and will continue long after we are gone. As we ponder these cultural and philosophical implications, let's shift our focus to the scientific debates surrounding the Nebula Hypothesis, exploring the arguments for and against this fascinating idea. Now shifting our gaze to the other side of the debate, let's explore the counterarguments to the Nebula Hypothesis. While the idea of living within a nebula is undeniably captivating, not all astronomers are convinced. Skeptics argue that the evidence supporting this claim, while intriguing, is not yet conclusive. For instance, the presence of cosmic dust and gas in our solar system could have alternative explanations. Some scientists suggest that these materials might simply be remnants of the solar system's formation, rather than signs of an ongoing nebula environment. Others point out that the interstellar medium, the space between stars, naturally contains traces of gas and dust, and their presence doesn't necessarily mean we're inside a nebula. Another point of contention lies in the nature of the Local Interstellar Cloud, the region of space through which our solar system is currently moving. While it shares some characteristics with nebulae, it's far less dense and lacks the vibrant, glowing features typically associated with these cosmic structures. Critics argue that calling this cloud a nebula might be stretching the definition, as it doesn't exhibit the same level of star-forming activity or visual spectacle. Instead, they propose that it's simply a region of slightly higher density within the broader interstellar medium. Additionally, the heliosphere, the protective bubble created by the sun's solar wind, complicates the picture. While it interacts with interstellar material, its boundaries are not well defined, making it difficult to determine whether we're truly embedded in a nebula. Some researchers suggest that the heliosphere might shield us from the full effects of any surrounding nebula, further muddying the waters. Without clearer evidence of how the heliosphere interacts with a potential nebula, the hypothesis remains speculative. Skeptics also highlight the challenges of detecting a nebula from within. Unlike distant nebulae, which can be observed in their entirety, any nebula surrounding us would be harder to study due to our proximity. This makes it difficult to gather the kind of comprehensive data needed to confirm the hypothesis. Astronomers would need to detect specific patterns of light, gas, and dust that are consistent with known nebulae, but such patterns have yet to be definitively identified. So, what would it take to settle the debate? Many scientists agree that more advanced observations are needed. Future missions equipped with cutting-edge instruments could provide clearer insights into the composition and structure of the interstellar medium around our solar system. Telescopes capable of mapping the distribution of gas and dust in greater detail might reveal whether we're truly inside a nebula or simply passing through a less remarkable region of space. As we weigh the arguments for and against the Nebula hypothesis, it's clear that this idea remains a tantalizing mystery. While the evidence is not yet definitive, the debate itself highlights the dynamic nature of scientific inquiry, where even the most intriguing ideas must withstand rigorous scrutiny. With that in mind, let's turn our attention to the future of nebula research and the missions that could bring us closer to answering this cosmic question. Now, as we look toward the horizon of discovery, let's explore the exciting future of nebula research and the missions that could finally shed light on whether we're truly living within a nebula. The quest to understand our cosmic surroundings is far from over, and scientists are already planning and launching groundbreaking missions to uncover the secrets of interstellar space. One of the most anticipated projects is the development of next-generation space telescopes. These advanced instruments, like the upcoming Nancy Grace Roman Space Telescope, are designed to peer deeper into the cosmos with unprecedented clarity. By mapping the distribution of gas and dust in our local interstellar environment, these telescopes could reveal whether the patterns around our solar system align with those of known nebulae. Imagine the possibilities: clearer images, more precise data, and perhaps even the first definitive evidence of a nebula surrounding us. Another promising avenue is the study of the heliosphere's boundaries. Missions like the Interstellar Mapping and Acceleration Probe, or IMAP, aim to explore the edges of the Sun's protective bubble and how it interacts with the interstellar medium. By analyzing the flow of particles and magnetic fields at these boundaries, scientists hope to determine whether the heliosphere is embedded within a nebula or simply passing through a less dense region of space. This could provide crucial insights into the nature of our cosmic neighborhood. In addition to space-based missions, ground-based observatories are also playing a key role. Facilities like the extremely large telescope currently under construction in Chile will offer unparalleled views of the night sky. With its massive mirror and cutting-edge instruments, this telescope could detect faint traces of gas and dust that might otherwise go unnoticed. By studying these materials in greater detail, astronomers could piece together a clearer picture of our interstellar environment and its potential connection to a nebula. But it's not just about telescopes. Space probes are also set to revolutionize our understanding. Missions like the Voyager probes, which have already ventured beyond the heliosphere, continue to send back valuable data about the conditions in interstellar space. Future probes, equipped with even more sophisticated instruments, could provide direct measurements of the gas and dust surrounding our solar system, offering definitive answers to the nebula hypothesis. As these missions unfold, one thing is certain: the next decade promises to be a golden age for nebula research. With each new discovery, we move closer to answering the profound question of whether we're living within a nebula. And while the journey may be long, the potential rewards unlocking the mysteries of our cosmic home are nothing short of extraordinary. So, as we eagerly await the results of these ambitious projects, let's continue to marvel at the wonders of the universe and the endless possibilities they hold. Now, let's take a moment to envision a universe where nebulae are not just distant, glowing clouds of gas and dust, but the very fabric of existence itself. Picture a cosmos where these vast, swirling structures are the architects of life, the birthplaces of stars, and the sculptors of galaxies. In this nebula-centric universe, every corner of space is alive with color and motion. a canvas painted by the forces of creation and destruction. Imagine standing on a planet orbiting a star born from a nebula. The sky above you is not the familiar black void dotted with stars, but a shimmering tapestry of light. Ribbons of gas stretch across the heavens, glowing in hues of red, blue, and green. The air around you feels charged with energy, as if the very atmosphere is alive with the remnants of the nebula that gave birth to your world. Every sunrise and sunset is a spectacle, as the light from your star filters through the nebula's gases, creating a kaleidoscope of colors that dance across the horizon. In this universe, nebulae are not just passive observers of cosmic events, they are active participants. They shape the orbits of planets, influence the formation of solar systems, and even play a role in the evolution of life. The complex molecules that form in these clouds of gas and dust could be the building blocks of life, scattered across the cosmos by the winds of dying stars. Imagine civilizations rising on worlds bathed in the light of a nebula, their cultures and technologies shaped by the unique conditions of their environment. But what if we are already living in such a universe? What if the Nebula Hypothesis is true and our solar system is embedded within one of these cosmic clouds? The implications are staggering. It would mean that the very air we breathe, the ground beneath our feet, and the stars above us are all part of a larger, interconnected system. The beauty of the night sky would take on new meaning as we realize that we are not just observers of the cosmos, but participants in its grand story. As we ponder this possibility, let's remember that the universe is full of surprises. Whether or not we are living in a nebula, the idea invites us to see the cosmos in a new light. It challenges us to think beyond the familiar and embrace the wonder of the unknown. So, the next time you gaze up at the night sky, take a moment to imagine the universe as a nebula-centric realm, where every star, planet, and living being is part of a vast, interconnected tapestry of creation. What secrets might it hold? What stories might it tell? The answers are out there, waiting to be discovered. Now, as we step into the realm of imagination and reflection, let's turn the spotlight to you, our incredible audience. What do you think about the possibility that we might be living in a nebula? Imagine waking up every day under a sky painted with swirling colors, where the very air around you hums with the energy of a cosmic cloud. Would you want to live in such a breathtaking environment? Picture the challenges and wonders. Visibility might be limited, but the beauty of a nebula-lit sky could be unlike anything we've ever seen. How would it change your perspective on the universe to know that we're not just floating in empty space, but embedded within a vibrant, dynamic nebula? This idea isn't just about science, it's about how we see ourselves in the grand scheme of things. If we're truly part of a nebula, it means we're connected to the very processes that create stars, planets, and perhaps even life itself. How does that shift your understanding of our place in the cosmos? Does it make you feel more connected to the universe, or does it spark new questions about what else might be out there? We'd love to hear your thoughts. Drop a comment below and let us know, would you embrace life in a nebula, or does the idea feel too far out of this world? How does this hypothesis change the way you look at the night sky? And if you could ask an astronomer one question about this theory, what would it be? Your insights and ideas are what make this journey through the cosmos so exciting. So don't hold back, share your perspective and join the conversation. As we bring this cosmic journey to a close, let's take a moment to reflect on the incredible idea that we might be living within a nebula. From the swirling clouds of gas and dust that paint the universe with color, to the possibility that our solar system is embedded in this vibrant cosmic environment, the Nebula Hypothesis invites us to see our place in the cosmos in a whole new light. We've explored the evidence from the presence of interstellar dust and gas in our solar system to the protective bubble of the Heliosphere, and considered how these clues might point to a nebula surrounding us. We've also delved into the awe-inspiring beauty and challenges of such a reality. where the night sky could shimmer with the glow of a cosmic cloud, and where our very existence might be intertwined with the birth of stars and planets. But perhaps the most fascinating part of this idea is the mystery it leaves us with. If we are indeed living in a nebula, what does that mean for our understanding of the universe? Are there other cosmic secrets waiting to be uncovered, hidden within the swirling depths of these celestial clouds? As we gaze up at the night sky, let's remember that the universe is full of wonders we've yet to fully comprehend. What other mysteries lie beyond our reach, waiting for future generations of astronomers and dreamers to uncover? So, as we wrap up this exploration, we leave you with this thought. What if the universe is even more extraordinary than we've ever imagined? What if the answers to some of our biggest questions are hidden in plain sight, just waiting for us to look a little closer? The cosmos is vast, mysterious, and endlessly fascinating, and the Nebula Hypothesis is just one piece of the puzzle. Keep looking up, keep wondering, and who knows what you might discover. If you enjoyed this journey through the stars, don't forget to like, share, and subscribe for more mind-expanding content. And let us know in the comments what cosmic mystery would you love to explore next. Until then, keep dreaming, keep exploring, and remember, the universe is full of surprises. Now, as we reach the end of this cosmic exploration, let's take a moment to connect. If this journey through the stars sparked your curiosity, don't forget to hit that like button and share it with someone who loves pondering the mysteries of the universe. Your support helps us keep bringing you more mind-expanding content like this. And if you haven't already, make sure to subscribe and ring that notification bell so you never miss out on our next adventure into the cosmos. We'd also love to hear from you. What do you think about the idea that we might be living in a nebula? Does it change how you see the night sky? Drop your thoughts in the comments below and let us know what other cosmic mysteries you'd like us to explore in future videos. Whether it's black holes, distant galaxies, or the search for extraterrestrial life, your ideas could inspire our next deep dive into the wonders of the universe. Until then, keep looking up, keep wondering, and remember, the universe is full of surprises waiting to be discovered. Thanks for joining us on this journey, and we'll see you in the next video.